Photons, magnetic monopoles, physics. This is a video about how to make a magnetic monopole out of photons. It's actually, though, a video about how to make things that are eentsier than Planck's constant. I read about quantum-linked photons at a variety of places online, among them a New Scientist article on a thing known as a quantum camera. Now, quantum-linked photons are photons where if one of the photons is absorbed at a surface, among other effects, the other photon is particularly noticeable with a computer image sensor. Now, when you think about it, it's a perspective that there are physicists that say that the Planck length is the eentsiest form of granularity. Now, what I'm about to describe describes a much eentsier version of granularity, which could actually be analog. If you have 2 quantum-linked photons, or 100 quantum-linked photons, and then have them, just one of those be absorbed, or 99 of those be absorbed, then that causes the variation of activity at the reference photon of the imager to be adjustable. So if you adjust the volumetric spatialization of the plurality of quantum-linked photons, you can actually cause photon variations at a size that is eentsier than Planck's constant. So apparently Planck's constant is divisible with quantum-linked photons. So making it so that Planck's constant, or the Planck length rather, is eentsier than the previously thought of Planck length has many effects. Among them, it could affect the MWI, the many worlds interpretation of physics, because the quantity of universes thought to be generated among supporters of the many worlds interpretation of physics actually relates to the Planck length as well as Planck's constant. So creating MWI events that are based around numerous quantum-linked photons simultaneously actually creates a different universe multiplier. So, now, what does this have to do with magnetic monopoles? Well, I read about a thing known as a Halbach array. The Halbach array is actually an array of magnets that a person could look up at Wikipedia, where the effect is that there's hundreds of times greater magnetic effect at a particular directionality of the field than the other. Now, one of the applications of Halbach arrays is brushless DC motors. They have this thing where basically at a tube there's a continuous magnetic field of only one polarity. So the Halbach array, even though it's an array of actual magnets, is able to create something that looks like a magnetic monopole because it's hundreds of times stronger in a particular direction. Now, photons, waves, as they travel, are actually linked with an electromagnetic field. So if you have a whole bunch of quantum-linked photons moving, producing an electromagnetic field, while having hundreds of those contribute to a quantum-linked photon event that is eentsier than the Planck length, eentsier than Planck's constant, you could actually weave those photons together so that they're like a traveling Halbach array through volumetric space, so that they produce what macroscopically would appear to be a magnetic monopole at the Planck's constant Planck length, while actually being slightly different than a magnetic monopole at things much eentsier than Planck's constant. So among physics that I've previously heard of, this would be an actual magnetic monopole at the observable universe prior to quantum-linked photons. So that's a way to create magnetic monopoles out of traveling photons that have magnetic monopolarity. However, at eentsier sizes, they're actually just traveling Halbach arrays.